There are several different types of factoring techniques. The first one, the basic one, GCF, or greatest common factor. If there's a common term like a, you can take out of both expressions, you can factor and write the rest in parentheses. Difference of squares. If you have two terms, so they're perfect squares, you can take the square root of. The factor would be two parentheses, a plus b and a minus b. New to Algebra 2, difference of cubes, a cubed minus b cubed. If you can take the cube root of each term, the first parentheses would be a minus b, and the second parentheses is a trinomial. We'll have a squared, and then positive a times b, and then plus b squared. Difference of cubes, we'll have a minus b at the beginning, and the middle term will be a times b positive. Sum of cubes is similar to difference of cubes, but it's the addition of two perfect cubes. Again, taking the cube root, we'll have a plus b for the first parentheses. The second parentheses, the trinomial, is exactly the same as the difference of cubes. The only difference is you have minus ab instead of plus ab. Perfect square trinomials. If you have a perfect square trinomial with a squared and b squared, and the middle term is either positive 2ab or minus 2ab, you can factor that into one factor squared, either a plus b or a minus b. And the last term, grouping. Factor by grouping is when you have four terms. We'll factor the first term using greatest common factor, taking out the common term, in this case x, and the last two terms will take out the common term, in this case it's y. When you do factor by grouping, both of the two parentheses left over should match up, and your terms outside, x plus y, will be your first parentheses, and the parentheses that matched up is your second factor, a plus b. Title of the first section today is Factor. First question, 6x squared y squared minus 2x y squared plus 6x cubed y. When factoring, you can look back at the formulas or think about different ways to factor. The most basic way to factor, though, when you have numbers in common, is the greatest common factor. Looking at the coefficients, 6, 2, and 6, we can take out a common factor of 2 for the coefficients. Each term also has the variable x, so we can take out a single x, and each term also has a single y, so we can take out a single y. We can only take out a single x since the second term only has x, and we can only take out a single y since the last term only has y. Factoring from here, we'll take 2xy or divide each term by 2xy. So the first term will be left with 3. Factoring out an x and a y, we'll have 3xy. Second term minus. Factoring the 2 out, we'll still be left with the negative. Factoring the x out, we'll have no more x's. We'll have y squared. Factoring out a y, we'll have a single y left. And the last term, 6, we're factoring out a 2, so we'll be left with 3. Taking out a single x from the x cubed, we'll have x squared. And taking the y out, we won't have y's in our last term. So always a good idea to double check after you factor, see if there's any other terms you can factor out or use any other factor techniques. In this case, you cannot. So our final answer is 2xy times 3xy minus y plus 3x squared. Second question is x squared minus 9. Factoring this term, there's no common terms to take out, but this term does match up with one of our factoring techniques, difference of squares. We can take the square root of x and also the square root of 9. Whenever you have the difference of squares, we'll have two binomials for answer. Square root of x squared would be x. Square root of 9 would be 3. And for difference of squares, we'll make one factor a positive and the other factor a negative. So we'll have x plus 3 and x minus 3. And last term we'll factor for the section, x squared plus 8x plus 16. If you wanted to, you could factor this using the diamond method, but this also matches up with one of our factoring techniques. If we have x squared, that's a perfect square. 16 is a perfect square. And if you take the x and the 4 and you double that, we'll have 2ab in the middle, which matches up with a perfect square trinomial. So if you recognize this is a perfect square trinomial, we can write it as x plus 4 squared. But again, you could also factor this using the diamond method and come up with the same answer. Of the first section is write a quadratic equation. In this section, we'll take a graph or the roots for a quadratic equation and write the equation from there. First question is a graph of a parabola or quadratic equation. The parabola crosses at 2 points. The first point is at -3 on the x-axis, and the second point is at +1 on the x-axis. The 2 points that the parabola crosses the x-axis are the solutions to this graph. So the solutions are x equals -3 and x equals 1. Taking these two values, we can write the quadratic equation. If we know one answer is -3, one of the factors will have to be x plus 3. The opposite of -3 gives us the +3. And the -3, if we plug it in, will make this value 0, which will be a solution to the quadratic equation. Second value of +1, if we do the opposite of +1, x minus 1, that again will give us a value of 0, which again will be a solution or root for the quadratic equation. And we'll set this equal to 0 for the quadratic equation. Simplifying this, we can multiply or FOIL the two parentheses. Foiling the first terms, x times x would be x squared. Multiplying the outside terms, x times a -1 would be -1x. Multiplying the inside terms, 3 times x would be 3x. And multiplying the last two terms, 3 times -1 would be -3, equals 0. Combining like terms, we'll have x squared, -1x plus 3x would be 2x minus 3 equals 0, and that will be our quadratic equation for the graph. Second question and last question for the section. We're given the roots to the quadratic equation. One root is -4 and the second root is -7. The roots are the same as the values where it crosses the x-axis, or the solutions to the quadratic equation. So solving, if one root is -4, one factor has to be x plus 4, because again, if you plug -4 in, this will give us 0, which will be an answer to the quadratic equation. The second factor, if we have 7, we do the opposite, which will be x minus 7, and we can set this equal to 0, since we have these solutions for the quadratic equations. Simplifying from here, foiling x times x would be x squared. The outside terms, x times a -7, -7x. The inside terms, 4x. And multiplying the last numbers, -28. Combining like terms, -7x plus 4x will be -3x minus 28. So our equation, given the roots, is x squared minus 3x minus 28 equals 0. Title of the last section today is Solve by Factoring. and then graph. In this section, we'll solve quadratic equations by graphing or by factoring, and then after factoring, we can graph the quadratic equation. First equation is x squared plus 5x minus 24 equals 0. Factoring from here, again, we can draw the x or the diamond method. Negative 24 would be the top number that we're multiplying to, and 5 would be the bottom number that we're adding to. So two numbers that multiply to get negative 24 and add to get 5. Those numbers would be 8 and negative 3. Writing our answers out in factored form, this would be x plus 8 and x minus 3 equals 0. After we factor, we can solve this equation, and taking our solutions, we can graph. We have two parentheses being multiplied together that equal 0. Using zero product property, one of these parentheses or both of them have to equal 0. So x plus 8 has to equal 0, and the second parenthesis, x minus 3, could also be 0. Solving the first equation, subtracting 8 on both sides, we'll have our first answer of x equals negative 8. And our second answer, if we add 3 on both sides, we'll have x equals 3. So the two answers to the equation, x equals negative 8 and x equals 3. After we solve, we can take these two answers and graph the quadratic equation. Drawing the xy axis. Our first answer, x equals negative 8. We can go out to negative 8 on the x-axis. And since x equals negative 8 makes the equation 0, the y value would be 0. And x equals 3. Since 3 makes the equation 0 or is a solution, that also makes y equal to 0. Since this is a quadratic equation, we know the graph has to be a parabola shape. We have two solutions to the graph. The graph is also positive x squared. Since we have a positive x squared, the parabola must pass through both points, and the parabola must open up. And that would be the graph for the formula. Second question and last question for the section. The equation x squared equals 81. Solve this equation. We'll first take the equation and set it equal to 0 by subtracting 81 on both sides. So we'll have x squared minus 81 equals 0. From here we can factor x squared minus 81. Since 81 is a perfect square, we can take the square root of 81, which is 9, and the factors would be x plus 9 and x minus 9. Solving from here, we can take each parentheses, again set it equal to 0. Since we're multiplying, one or both of these parentheses have to equal 0. So we'll have x plus 9 equals 0, and x minus 9 equals 0. Subtracting 9 from the first equation, we'll have x equals negative 9, and adding 9 on the second equation, we'll have x equals positive 9. So our two answers from factoring and solving the equation is x equals 9 and x equals negative 9. Last part we can graph using these solutions. Drawing the xy axis. Our first answer, negative 9. We go to negative 9 on the x-axis. And again, the y value would be 0, since the equation negative 9 is a solution to equal 0. And x equals 9 will be our second solution. Since this was a quadratic equation with x squared, we know the shape of this graph is a parabola. It was also positive x squared. So we can draw a parabola going through both points, and a positive x squared, the parabola would open up, and that would be the graph for the section.